So we're continuing with the method of partial fractions, and we did some background on the method and general format of it. Sometimes it's easier that we start with something simple and give a few examples, and then you go back to that background again. And then it all makes sense. So there should be a back and forth between the examples and the background to make a concrete case for you, basically. So I'm starting with this example. This example actually turns out that we've done this in the when we were doing trig substitution, basically. And it's just the 3x equal to secant of theta, and then you solve and you get the answer. And again, trig substitution, sometimes I feel like you only want to use them for specific basically kind of situations. Like if I have a square root of that, trig substitution is the best way to do this. But if it's right now I have this quotient, and I know the method of partial fraction is going to help me do this quotient as well. So I'm going to try to do this by the method of partial fractions, even though I already know other methods. And then I'll eventually our examples are going to present to you examples that you cannot do with other methods, basically. So now here, so the first step that I'm thinking about is this. What is the integrand? Integrand is, so step 1 over x squared minus 9, and the degree of the numerator is less than degree of denominator. Degree of numerator is 0. Degree of denominator is 2. So step 1 checks. Then step 2, I want to basically, I want to make sure to factor the denominator into either linear or quadratic that doesn't have a real solution. And this one is an easy one to factor. X squared minus 9 is just x minus 3 times x plus 3. Check. Step 3 is that I want to set up the integrand into basically more manageable, what is it called, quotients. And in this case, 1 over x squared minus 9, and what I'm going to do is write every linear factor starting from degree 1, and this one ends with degree 1, so just 1, and then the other linear factor starting from degree 1, and it ends with degree 1 because it's just that's what I have right now. And then imagine that I will have a constant in here and another constant in there. For linear factors or linear to a power, you always have a constant for the numerator. For the quadratic one, you will always have a linear for the numerator. Now, step 3 is also solving for this a and b, basically, or we can, yeah, we want to solve for this a and b. So how do I solve for a and b? Let's say, yeah, I want to find a and b, but imagine if I was given the right side, what would be my first step to do? And generally in algebra, and the first step is to make a common denominator and so on and so forth. So I'm gonna rewrite the right hand side with a common denominator, which is x minus 3 times x plus 3, which is the same denominator that I started with. And then when I'm adding them up, if I'm doing a common denominator, basically I'm multiplying the first fraction top and bottom by x plus 3, so I will have a times x plus 3, or they sometimes call it a cross multiplication or something in this case. Not all of them are like that. Again, if the powers are more than 1, you have to be careful. And then over here you will get b times x minus 3. And then so because I want this to be equal to that, all I need to do is to show that to find a and b such that a times x plus 3 plus b times x minus 3 is equal to 1. So how do I do that? So I want 1 to be equal to a times x plus 3 because the numerators are the same, right? Plus b times x minus 3. Now what I want to do is basically, this is for every x, right? And so what I want to do is basically find the coefficient of x. And since this side doesn't have any x in it, the coefficient of x on the right should be equal to, should be set equal to 0. And then I want to find the constant value on the right, and that should be equal to constant value on the left, which is 1. And so now at this point is 1 equal to ax plus 3a. I multiplied everything through, distributed, and put the x's together. Ax plus bx is a plus b times x, and then the constant. And that this entire thing says, because x is any number, it's going to be a plus b is equal to 0, and 3a minus 3b equal to 1. And so I can plug back in, a is equal to negative b, or b is equal to negative a, and I will get 6a is equal to 1, or a is equal to 1/6, and then b is equal to negative 1/6. That's the solution. So what happened is that now I'm saying in the next step, oh, let me finish this up before I go to the next step. So what I'm saying is that 1 over x squared minus 9 is equal to a over x minus 3, see a over x minus 3, plus b over x plus 3, right? So I did that partial fraction for the integrand. Now let's integrate. That's the last step. 4, and integration is going to be equal to integral 1/6 comes out, 1 over x minus 3 dx minus 1/6, 1 over x plus 3 dx. And you want to set x minus 3, the use substitution x minus 3 for the first one, use substitution x plus 3 for the second one. And now that you're faster at doing that, I'm just going to write down the next answer. So it would be 1/6 of natural log of x minus 3 minus 1/6 of natural log of x plus 3 plus c. And that's the final answer. So this was the simplest part, the simplest example we give, and it is a good example. Write it down, make sure that you know all the steps, so we can go one step up and follow. By the way, there are other things that you can do. You can put the natural logs together, because if you have used other methods, that the answers are going to be, you have to basically do a little bit of algebra here to get the answers that you got from the other methods, basically. But yeah, go over this, make sure you're comfortable with this, and then watch the next video.